Well, welcome everybody to our last session of the day. I want to introduce you to Shaun O'Meara, our field CTO. Hey, Shaun.
Hey, Nick. Good afternoon. It's been a crazy day.
It has.
Yeah, it's been a busy run up to today and a busy day with a lot of great things going on. We've heard from Adrian on his strategy this morning, the great way that Mirantis is moving forward. We announced our new product line. We spoke about the new Docker Enterprise Container Cloud line, new future for Mirantis. We had a great lineup of customers share their story. We introduced Lens, following on the Lens launch a couple of weeks ago. And we're introducing new great projects like our Mosque project, new way to deliver OpenStack going into the future. And then in parallel to all this, we ran a great tutorial track that teaches you all about how to use these new products. And hopefully you'll go and everyone's had an opportunity to go and look through those.
Yeah, so what's next?
What is next? Yeah. Lots going on. A lot of new things that we're thinking about for the future. Obviously, a lot of work to do on what we have right now. A lot of great things coming. But, we've had this opportunity to talk about all these cool things that are coming down the road. And everybody these days seems to be talking about topics like edge computing or hybrid cloud or, hyperscale data centers, even things like disaster recovery as a service. And, we talk a lot about things like hyperconverged, but frankly, it's boring. Let's find something a little bit more interesting to talk about. You and I have been talking about these topics for a while now, and I think it's about time that we spoke about some of the cool things that we're thinking about for the future. Not necessarily looking at for the roadmap, but ideas for the future, things that could have an impact on the way we do business going into. So today we're going to talk a little bit about things like pervasive computing. And Nick, what is pervasive computing?
Well, basically, pervasive computing is when everything that you interact with, for the most part, is computerized. So in some ways, we're already there in that, your phone is a computer, your refrigerator may have a computer in it, your smartwatch, your car has a computer in it. And the most obvious sign of that is this whole Internet of Things, where your vacuum is connected to your phone and all of that. And so pervasive computing is this sense of you don't even really think about it. You just kind of assume that everything is computerized.
So how is that different from ubiquitous computing?
Oh God, you hit my hot button. Okay. So if you look, there are a lot of places that will say that pervasive computing and ubiquitous computing are the same thing. They're not the same thing. Don't use them interchangeably. They're not the same thing. Ubiquitous computing is where you can do your computing virtually anywhere. So, for example, I've got a document. I started it on my laptop. I can then go and finish it sitting on the beach on my phone, or I can go and do it in a coffee shop or a library or wherever. So the idea of ubiquitous computing is similar in that, yes, there's computing everywhere, but it's more about your data being universally accessible. So essentially, it is cloud computing. That is what this whole ubiquitous computing thing is about.
Okay, and that then differs from pervasive computing in the fact that pervasive is the devices that we have all around us versus the access to those devices.
Exactly. It's more about the data. So ubiquitous computing is more about my data is stored in some central place and I can hit it from anywhere there is a device. Whereas pervasive computing is there is a device almost everywhere.
Okay.
So, cool. Yeah.
So why do we as Mirantis care about pervasive computing?
Well, pervasive computing brings up a whole lot of new issues, and it's coming up really fast. I mean, last night I was watching, a commercial where, a woman's coming out and starting her car with her phone, which sounds really cool.
Mm-hmm.
But what they say, anything that you can access, with your computer is hackable.
Yeah.
So, there are security issues that need to be considered when it comes to all of this. But that's a downside. But there's just this huge upside on pervasive computing that is so exciting when you think about this. I mean, think about a world where, remember I said your refrigerator might be attached to the network. Well, what if you could rent out space on your refrigerator to somebody someplace else in a secure way, of course? What if you could define your personal network as all of these devices that you own, and it doesn't matter where your workloads run? Or, you could define all of this stuff in such a way that the connectivity between objects is really huge. So, you look at things like, IFTT, it's like, get a notification when the International Space Station passes over your house. Okay, I don't know why I would need that, but it's the kind of thing that people would
If
never
you've
have
got a
thought
9-year-old, you can run him outside and show it to him.
That's true.
There are those advantages.
There you go. There you go. So, that kind of level of connectivity between objects is really, really, it gives us this new level of functionality that we would never have even considered even 10 years ago. It also extends the life of objects that we already have. So, maybe you've got that computerized vacuum cleaner, and you don't like the way that you don't like the pattern it uses in your house. So you reprogram it. Or I watched a guy decide that he didn't want to buy multiple vacuums for his house, so he programmed his programmable vacuum to fly between floors. It was actually pretty funny. Some people just have too much time on their hands.
It's driving the whole world of programmable at all levels.
It really is.
Like the projects coming out of the car industry of creating a programmable car would fit into that category then, I suppose.
Absolutely. These developer toolkits that make it possible for anybody to reprogram these devices that you never would have thought of reprogramming before. So
cool.
It's important.
So do we want to talk about the questions we would love people to give us some feedback on at this stage?
I would love to talk about these questions. So what we did is we put together a place for you to answer questions if you're not watching this live. If you're watching this live, please go ahead, drop your ideas in the chat. We would love to discuss them. Do you want to see more of this, or conversely, does it scare you? Shaun, what do you think about these questions?
Well, for me, the whole idea of a connected world, at one level, the engineer in me loves the idea. Another level, it comes to beggars questions of privacy, beggars questions of how do I control this going into the future? What prevents somebody from taking over my flying vacuum cleaner and using it? So it's an interesting question. I think there's a lot of cool ideas here and a lot of work to be done. Really want to hear other people's ideas as well and see how we can take this into the future.
Definitely. Look, we're joking about it, but when somebody hacks into your grandmother's insulin pump, maybe not so funny.
No, exactly, and a very real risk in this.
A very real risk. But yeah, we'd love to hear how you'd like to see this used. So that's my that's kind of what I've been thinking about these days. But Shaun, now I know you are really concerned about this whole issue of developers and how they feel about infrastructure. So I would love to hear what you've got to say on that.
Yeah, I'd love to talk a bit about that. We've done a lot of work over the last few years looking at how developers. Our history has been very focused on operations, but with our big drive towards supporting developers, providing better infrastructure for developers, one of the interesting things that keeps coming up to the fore, and the way the world is changing, is that the big question is: do developers actually give a damn about infrastructure in any way, shape, or form? Ultimately, more and more development languages and tools abstract that underlying infrastructure. Right? What Kubernetes does is it basically abstracts the infrastructure away. More and more options are coming to market, which you can quite literally create an application without ever writing a line of code.
I did it this morning.
There we go. We're doing it all the time, sometimes without even realizing it. And I think the definition of what a developer is also changing to a certain extent. So, the big question which I have and which I'd like to understand more, and from talking to a lot of developers, is: do developers care about infra? What is it that you expect from infrastructure? What do they want going into the future? How are they going to interact with that infrastructure? My personal opinion is that they don't really care about infrastructure, that they're going to find more ways to completely abstract away from that. And they just want to focus on delivering applications faster and getting value to market. But I might be wrong. And I'd really like to hear people's impact, ideas, and thoughts on that.
That's exactly it. That's why we're asking this question. Developers out there, do you care? Or do you just want the whole thing completely abstracted away from you?
And if you do care, why? And if you don't, what would you like to see? I know that's a couple of questions to ask, but really like to hear those opinions. And, do you just want the operations guys to live with it? You never want to hear about it again, which is fine. It's absolutely good to say that. We'll work it out.
Yes, that there's nothing wrong with pushing that up the stack.
Yeah, pretty much what we're trying to do here.
Well, it is what we're trying to do, but at the same time, we want to do what's good for developers. And if you developers are like, no, don't do that. Well, we want to know, because we don't want to work our way here in some ivory tower and wind up with something that's not good for you.
Absolutely. No, for sure.
So
cool. So
now,
there are some other interesting things we're talking about.
I know. This is one of my favorites. It's
related to this.
Yes. So while we're on the subject of not getting involved with the infrastructure, go ahead, Shaun. Tell us about it.
This is a pet topic of mine, and something that we've spoken about a lot. And next, something that we have spent many nights talking about. And the idea is AIOps, using artificial intelligence to drive operations within our infrastructure. And so a lot of people ask me, why? And essentially, what the hell is AIOps? And I've answered this question many times, and it does often seem that we all take this AIOps thing for granted or look at it in a different way. So to me, it is essentially, it's automation on steroids. That's what it boils down to. It's using intelligent systems to replace the human cerebellum. I mean, let's just be blunt about this. We're trying to replace humans. And the reason for that is we humans, or us meat sacks, are error prone. We make mistakes all the time. And compared to computers, we're incredibly slow. That's really the simplest point here. With the scale of modern infrastructure that we're dealing with, the sheer volume, I mean, we've gone from, thousands to tens of thousands of VMs to now hundreds and thousands of containers spread across multiple time zones, multiple places. we need to come up with better ways of managing this. And the old-fashioned step-through mechanism of automation is just too limited for that.
Right. And when we
So
say we want to replace meat sacks, we mean in a good way.
we mean in a good way. I know it's a bit of a harsh way of putting it. Ultimately, humans have ability for creativity that machines just don't have.
Right.
But machines can do other things, and they can do analysis of data a lot faster than we can. Quite often we have to present that data to humans to have them validate that information. But one of the options for us is to use artificial intelligence, quantify data, correlate it, look for root cause, and then provide that information to us in such a way that we can make valid decisions based on that information a lot faster than we could otherwise.
Right. So what are the implications? What are the practical implications of doing this?
So practically, we can analyze massive amounts of data a lot faster than a single human could, or even just a normal type system that's searching. We have the tools to learn by looking at data, and have machines do it a lot faster than we can. We can take action faster based on that data. Because we get the data faster, we can take action, and much more complex action that involves maybe many different layers of tasking much, much faster. And we can start to do maintenance operations and maintenance tasks without having to wait for human beings to wake up or get to an office.
Right.
But more importantly, we can start making tasks happen, very complex tasks in very specific orders, with much less potential for error. And those are the kind of areas that we're looking at.
That's true. So how do you kind of see this moving forward? I mean, obviously, we're not going to go from nothing to Skynet, and hopefully we never get to Skynet.
Well, depends if you're in control of Skynet or not. Ultimately, Skynet is still a computer. Practically speaking, we have a few hoops to jump through, I suppose, before we can look at where AIOps is going to be really effective. And the first one is a trust issue. We have to learn to trust it. And to do that, we have to put it in a position where it can learn and start providing us that data analysis and that inference, and then having humans validate it. That's practically the very first step. It's a trust issue. We've been watching sci-fi for the last 30 years plus, and the computers take over. Well, ultimately, is that real or not? If we look at how we're going to get there, probably midterm, adaptive maintenance, maybe infrastructure orchestration, smart allocation of resources across cloud services.
Well, no, can you talk for a minute about what that would actually look like? So, I mean, we could talk about, AIOps midterms. I mean, in a practical sense, how would that actually work?
Yeah, okay. No, it's a great question. So practically speaking, the first thing we're going to do is we're going to start to collect all this data. We've got to find all this data. I mean, the modern computer systems that we have, infrastructure systems, we are producing many hundreds of gigabytes, sometimes terabytes of logging data every day. The majority of it gets file 13. I mean, we throw the majority of that logging information away, or if it's not thrown away, it's stored somewhere for security purposes and never analyzed. So let's start by taking that data and actually analyzing it. To do that, we need to collate and correlate it. So we've got to put it all together, we've got to match it, and we've got to start building patterns. We've got to start looking for the patterns. And this is where AI is particularly good at starting to help us build patterns, start to look for those patterns. Initially, humans will have to do some training. Once we have that patterns, once we've got that working, we can now start having the AI system start to do some inference, i.e., here's the root cause. So the system can tell us, based on the data, based on the patterns we've been learning, we know from the past that if those 3 network links get full, bad example, we're going to have a failure in region X.
Right.
You know. So start telling us, well, those network links are filling up. Tell us before they're full, rather than after they're full, or as they're filling up, as we see trending information. Now, seems a bit simple. I could do trending information with just normal monitoring systems. But if I can start to correlate that with greater users in, Beijing office versus users in the California office, filling up those links in different times of the day, I can now start to make much more clever decisions, which is a human on their own to try and correlate that information would just be insane.
Yeah.
Once we've done that, we can go to the next stage, which is start to have the system do actions for us based on that information.
Right.
Now we're starting to get closer to the Skynet. Practically speaking, though, this doesn't have to be a big, complex pile of change. Smart AI solution, I have data, and that AI solution is talking to my existing automation solutions to action that change. And that's how I see this moving forward. Right.
So essentially, you, instead of saying, deploy this to this workload to AWS, you would say, deploy this.
Yeah.
And then the system would look and go, okay, it's this kind of workload at this time of day, at this size, it's going to interact with this and this and this. And so it's going to be best off in this region of this cloud provider. And then, 2 days from now, when the prices drop, we're going to put it over there.
Even taking a different stroke on exactly that, it could be the Beijing office is coming online. Let's move the majority of the workload to a cloud that's closer to them, reducing the network bandwidth costs and inference, and also reducing the impact on international lines. As Beijing winds down for the day, I can just move the majority of that workload into California. And Europe in between. It's very simple examples, but to have humans do that would be very complex and very time consuming.
Exactly. And just having humans notice those patterns would be difficult. But once you have the system noticing those patterns, then the humans can start to think, how can I take advantage of this? So as you are talking about much longer term in the actual applications themselves.
Mm-hmm.
So, everything can be optimized that way. So
everything can be optimized. I mean, we can optimize down to the way we even potentially write applications in the future. Humans will still decide on the base logic. Humans will still decide on the creative components of that. But as we build things, we can start to optimize them and break them down into smaller and smaller units that are much more specific. But the complexity goes up when we do that. So we can start to use AI and AI solutions to start to manage that complexity across multiple spaces, multiple time zones, etc.
Exactly. So that's the question. What do you guys think? We really want to know.
And here again, we mentioned this right at the beginning, but do you think you could trust an AIOps solution? What would it take for you to trust an AIOps solution? And where do you practically see it being used in the short term?
Yeah, that's the big question, is where do you see it being used? Where would you like it to be used? Is there something that you don't think would be possible, but you would like to see it? But the main thing is on a practical matter, what would you like to see?
Let me ask the question in a slightly different way. Do you have a problem that we could solve with an AI solution today? An AI solution.
There you go.
Real world problem.
Right, a real world problem, and assuming that we are not going to take over the world. It's important.
My evil plan is to take over the world with AI.
Oh, man, I'm so sorry for
You had to let that drop.
I did. I'm so sorry. All right. So that's AIOps. And like I said, if you're watching this live, throw it in the chat. We want to hear your ideas. If you're If you're doing this, if you're watching this on the replay, go to the survey because we really want to hear your ideas and your opinions.
Absolutely.
All right. So moving right along. All right. What the heck are Unicornos?
Lovely question. So the whole world is talking about containers today.
Yeah.
We are talking about containers today. But containers like VMs are just one way to handle compute. And there are more and more ideas that are out there today, and people have been trying different ways of shrinking the size of the compute environment, the compute platform. And another cool way of looking at this, and something that's been around for a little while, but it's getting a bit of traction at the moment, is something called Unicornos. And what they are is they're basically highly optimized executables that include the operating system. They're an OS, a set of libraries, and some very simplified application code all mixed into a very, very tiny package. Easiest way to describe them. They're super simplified. And we're talking about in the AIOps discussion, this idea of taking everything into smaller and smaller individual functions, but creating a certain level of complexity. Well, if we look at Unicornos, those are those smaller and smaller bundles and functions. They interact directly with the hardware or through a hypervisor. Virtually no overhead. I mean, the overhead, if you just look at what a modern Linux operating system is made up of these days, there are so many different parts and components. Even just a kernel has got anything from 5 to 7 different parts to it, plus of course drivers and a bootloader. Then we look at the system libraries that sit on top of that, and then there are daemons and utilities and shells and screen components and additional kernel stacks that go on top of that for hypervisors. What we're trying to say is all of this takes up space.
I'm getting tired just listening to you.
Yeah, I'm tired talking about it. I mean, the unikernel really, it just takes away all that complexity. It puts the application, the OS, and the basic libraries necessary for that application into one really tiny package. To give you an idea of what we're talking about here, we're talking about memory footprints or package footprints in the kilobytes.
Wow.
A small container is considered 100 meg plus.
Yeah.
We're talking kilobytes. We're talking memory utilization in the kilobyte to megabyte space, because there's no fat, no fluff, no unnecessary components. And then only the CPU that it needs.
So Bill Gates was right. 640K is all anybody will ever need.
Potentially, yeah. I think there was an IBM CEO who said even less at some point. So we'll see how that goes.
There you go. What goes around comes around.
But one of the really interesting things about this small size, which is really critical, is how fast they can boot.
Yeah.
We're talking boot times measured in milliseconds.
Wow.
We're talking the ability to spin up specific functions only when you need them. Now, if we look at the knock-on effect of that, we're looking at power saving. I only run the app when I need it because there's no latency to start it up. The app is tiny, so I can pack a lot more into a lot less space. Again, power savings. But when I start looking at what you were talking about earlier, which is the pervasive compute idea and the IoT world, all of a sudden that tiny little ARM chip set in my Raspberry Pi that's running my fridge, or my Raspberry Pi equivalent that's running my fridge, no longer has a fat operating system around it. I can run tens, thousands potentially of these very tiny specific devices when I need them.
Wow. That's amazing.
So I'm kind of excited about it. I'm excited by the idea.
Yeah, I can hear that.
I'm a hardware geek from many, many moons ago. And so I kind of like the idea of being able to better utilize all this very low powered hardware that we have lying around and really take it into the future.
Well, that's good.
Yeah.
So
Not going to kill containers, but it is a parallel technology that I'm very interested in.
that is true. Now, what does it? I mean, in terms of like attack surface, that means it's got a much smaller attack surface, though, right?
Yeah, great point. I mean, there's no fluff, there's no extra components in the system. Therefore, the attack surface is very, very small. And because they're so small and can be distributed much faster and much more easily, updating and upgrading them is much easier.
Oh,
We can upgrade a 60 KB file across a GPRS connection, which I certainly can't do with a 600 meg or 4 gig VM 600 meg container. It's just unrealistic. We'd still
no,
Christmas.
no.
Go on.
No, I was just going to say. So now these Unicornos, they're so small, and they have only what they absolutely need. Now, how do you access the hardware?
So the hardware is accessed via a hypervisor. So you have to have some kind of hypervisor running on top of the hardware. But
Okay.
because we need very little from that hypervisor, we don't actually need to interact with that very much. That can be a very cut down operating system, very, very simplified operating system. We're also not trying to run another layer on top of that. We're not ending up with multiple potential VMs or something underneath it. We completely remove that layer. The drivers, the necessary drivers, are built into that particular kernel device.
Oh, okay. That makes sense.
Tiny footprint, easily distributed, and once again, very specialized.
Right. Well, that makes sense. Okay. So yeah, I mean, I guess so. These individual stacks, comparing virtual machines to containers to unikernels, they're just a completely different architecture. But I can see how that would work, where you have the hypervisor on top of rented teeth. Okay, so moving right along.
So,
where do we see these being used?
It's early days, although there are some very good practical applications out there. There's a big ecosystem of people trying different ways for this. IoT is the obvious immediate place. IoT is a quick, easy place for something very specialized. What's interesting to me, and you mentioned this earlier, we're talking about medical devices. We're talking about potentially disposable medical devices.
Yeah.
Now, if I can keep those devices to run on really low power, very, very cheap CPUs, and all of a sudden I've got a device that is available to a lot more people. I don't need a massive, powerful CPU. I just need something that runs a very specific function really fast at very small scale. I can build disposable devices. I can build medical devices that are so small we can potentially swallow them.
Yeah.
Other areas which are really interesting, and I spoke a little bit about it, but it's in the energy efficiency, where we need to be very, very energy efficient. And that can also impact on massively scalable systems. Where I want to deal with tens of thousands of potential transactions from users going into a system, I can spin them up only when I need them. I don't need to keep them running all the time. And again, it comes back to that low latency.
Right.
And then anywhere that an incredibly fast boot time is valuable. A car, think about it. If my electric car is constantly draining that battery when it's parked in the garage and I'm traveling, or if it takes 20 minutes for my car to boot up its Linux kernel when I want it, I'm going to get very irritated.
Well, that, and if you have a specific function, like identify that thing. Yeah, it would be good if you hadn't smashed into it before it identified it as a baby carriage.
That's where it gets very interesting.
I am dark today. Yes.
So Nick, these are all really interesting topics.
Yeah.
We spoke about AIOps. We spoke about the impact it's going to have on humans. All of these changes to the world that we're living in, from computer systems, the impact it's having on our lives, begs an interesting question about the ethics of all of this.
Ethics of all of this, yes, because let's be realistic. There are actual real concerns when it comes to privacy, when it comes to how corporations operate, when it comes to how governments operate. There are areas of the world where how all of this has moved is absolutely, I'll be honest, absolutely terrifying. The economic disparity. But when you really come right down to it, it's all about the human control over the technology, because all of these ethical issues are in our hands. Okay, we can joke about Skynet, we can joke about things like that, but this is one place that technology can't help us.
Yeah.
We have to do this. We have to be aware of what's going on. We have to be aware. Are they using facial recognition, when you go to XYZ? Are they using recidivism algorithms in sentencing, and how is that going? Is it are those algorithms fair? Do certain groups get longer sentences because historical data is skewed? Be educated. Know how this works. Don't be afraid of any of this. None of this is rocket science, really. You come right down to it. I mean, it's not simple, but you can learn this. You can do it.
Yeah, ask good questions.
Yes.
Be interested and be part of the discussion, not just a passive bystander.
Exactly. Don't just complain about what you think is going on. Learn about what is actually going on and be active where you see something that needs to be fixed. So that's what we can do about it. We need to be aware that there's an issue or potential issues, and we need to step in and fix it. So that's my soapbox. I'll step down.
It's an important topic, and it's one that we all can have influence on. And it's one, those of us who are actually involved in building these systems for the future, we can help make sure that the rules are there.
That's right.
Systems are built correctly, and that we have open dialogues and discussions around these points and topics in an ongoing way. Awesome.
That's right.
Well, I think we're coming to the end of the time, and hopefully we've kept everybody interested in some of the things that we think are cool for the future and we'll be putting our efforts into.
That's right.
But I think we need to wrap this up now. So, Nick, great chatting to you as always.
Always a pleasure, Shaun.
It's been an amazing week. It's been an amazing couple of weeks for everybody leading up to this event. And, thank you everybody for listening to us. Please go and download and try Docker Enterprise. The container cloud is available. We'll post the links here. To better understand what we've been doing, go and have a look through the tutorial track. You'll hear my voice. I'm sure you'll hear Nick's voice and many other people's voices through those tutorials. Hopefully we can keep you all interested. And then go and download and try Lens, please. And finally, we want your feedback. We're interested to hear what you think would be the great ideas. Good, bad, otherwise, let us know what you think of our products. We are striving to make them better all the time.
Absolutely. And we want your involvement.
Awesome.
All right. Thank you all. Bye-bye.
Ciao.